Hey everyone, so we are now moving on to solving equations with powers and roots that are not 2 or 1/2. Alright, so pause and figure out this do now. It's pretty easy. So you have a ball and it's rolling. Oops. Right, and there's a dot there. What would this be a description of? Hopefully you said it's, which one was it? Oh, D. The distance from the mark on the rim from the ground. Yeah, because as it rolls, it goes down as at the ground, and then it goes back up, and then it's down at the ground as it rolls. Because it's like the dot goes down, and then as it rolls, it comes up, Okay. So, we are going to be talking about perfect cubes, perfect fourths, perfect fifths, perfect sixths. I don't expect you to know all of them. I would definitely recommend knowing at least through x cubed. Most of the x cubes, a lot of the x to the fourths, a few of the easy x to the fifth, x to the sixth. I wouldn't expect you to memorize like the really big ones though. So I'm going to pause the video and just write them all out, and then you can just use your calculator and fill in your table. All right, so that's all of them. So like I said, I would recommend knowing those. I would say you should know up to 5. Like I know up to 5, so I think you should know up to 5 for x to the fourth. And then these, I don't know them, but I recognize them. Like when I see those numbers, I kind of am like, okay, that looks familiar. These, I have no idea. Like the fifth for 6 through 9, I have no idea what's happening there. Even like this one, I don't really know these very well either. Or this one. So definitely the thirds, fourths up to here, fifths, I would say here, sixths, just these two, in terms of memorization. But yeah, the big thing is like if you see a number, recognizing it. Like one that I recognize all the time is 2401. Like if you said, oh, what's 2401, I wouldn't know, but I'm like, okay, it's something. If I grab my calculator, I'll play around with it, and usually I can figure out, okay, it's 7 to the 4th. It might take me a little bit, but when I see that number, I recognize it as some perfect something. Okay, so we are going to simplify. What is the 216 to the 1/3? I said it. The to the 1/3 is the same as a cubed root. So look in your chart. What's the cubed root of 216? That is 6. So pause and try the rest of these. So because it's negative, this one is 1 over 81 to the 1/2. A 1/2 is the same as a square root, so that is just 1 over 9. For 25 to the 3 over 2, so that is a square root of 25 to the 3rd. If you want to write the little 2 in, you can. You don't have to. Now, order actually doesn't matter. It does not matter if you cube it first or square root it first. Just think what would be easier. Rooting is definitely easier, so I pretty much 95% of the time will take the square root first. So 5 to the 3rd is 125. The only time I wouldn't do the root first is if it was like a number that wasn't a perfect square. Yeah, so then I would just do the exponent first and then simplify. So number 4 is 1 over 32 to the 3/5. 1 over, that's the 5th root of 32 to the 3rd. And again, you could do 32 to the 3rd, but I don't know what that is. That's terrible. Let me see, I grab my calculator. 32768, and then I have to figure out the 5th root of that. That's obnoxious. But I know that the 5th root of 32 is 2, because I was a big nerd who was, when I turned 32, was like, I'm 2 to the 5th. You know you love my nerdiness. All right. What do you think for these? So if I have x squared equals 20, how do you solve that? Take the square root of both sides. All right. Right, so x equals, do we know the square root of 20? We don't. But what can we do to it? We can simplify it. 20 is 4 times 5. Right? Square root of 4 is 2. We don't know the square root of 5. Now, we lost a point. What did we forget? Anytime you take the square root of a square, you got to put plus or minus. All right, I want you to pause and see if you can figure out the other three. So same thing here, square root of both sides. So x equals plus or minus. What do we put there? Square root of 9 is 3, but we have a negative underneath. What do we put when we have a negative? That's your I. Don't forget I. Notice I put solve over all numbers. I didn't put real numbers. All right, next one, 512. What number to the third is 512? So that's 7. I don't even know them. 8? It's 8. So the cubed root is 8. Now, is it plus or minus 8? So think about this. 8 to the third is 512, right? What's negative 8 to the third? Well, a negative 3 times is a negative, so it's not plus or minus. Anytime you have an odd number, it is not plus or minus. So how about number 4 then? Is this undefined? Do we have an I? No, we don't, because again, it's a cube. That's just negative 5, right? Negative 5 times negative 5 times negative 5 is our negative 125, right? 5 does not work. That would be positive. All right, pause and try these on your own. All right, so x cubed, so we take the cubed root of both sides, and we just have the cubed root of 10. Can we simplify that? Does any perfect cube go into 10? No, the smallest one is 8 other than 1, so that's not helpful. All right, how about number 6 then? So cube root again. So you can write this as 2 in 2 ways. You can write it like that. I usually will put the negative on the outside because I feel like it's weird to leave it on the inside. So I do that, but I would not take off points for the top one. All right, whose fourth root is 81? That is 3. So x equals 3. Nope. Again, this is very similar to an x squared, right? So it's plus or minus. It's plus or minus 3 because negative 3 to the fourth will be a positive 81. 3 to the fourth is 81 because it's an even exponent, right? So this one, now this one's actually pretty tricky. So I do the fourth root. The fourth root of negative 16. So what times itself? 4 times is 16. So that's 2 plus or minus. And then is a negative under a root, we would think it's I. It's actually not. So this is super, super tricky. The fourth root of negative 1. Another way of writing a fourth root, it's really a square root of a square root. Right? Because remember, we multiply. Right? If you have x to the 1/2 to the 1/2, that's x to the 1/4. All right. So a fourth root is really a double square root. So the square root of the square root of a negative 1, that's the square root of I. So actually, and this is not, I actually had to look it up because I wasn't really sure. You are not allowed to just say, oh, this does not equal I. So we're going to leave it square root of I. There is an answer, but it's really awkward, so we're just going to leave it like that. All right, again, pause the video, see if you can do this. Number 10 is very difficult, just throwing that out there. All right, so fourth root again. So plus or minus the fourth root of 15. Nothing goes into 15. I'm going to skip to 11 and 12. X just equals 1, right? The fifth root of 1. X equals negative 1. All right, so now this is where it gets shady. All right, so we have the fourth root. So this is the fourth root of negative 1. And then we don't know the fourth root of 20, right? Nothing goes into 20. However, what perfect square goes into 20? 4. So this is how we're going to break it up. 4th root of 4, and then the 4th root of 5. So we said that, what did we say the 4th root of -1 was? It's the square root of I. Now, just like before, we're going to rewrite the 4th root as a square root of a square root. What's the square root of 4? 2. So now we're going to take these and put them together. So we got the square root of 2i times the 4th root of 5. And that's actually the fully, plus or minus, the fully simplified answer. It's very weird. Don't freak out. We'll go over it again, but it's not like the end of the world. Like this, I'm not going to like go crazy with these problems. And pretty much we only have to do this if it's to the 4th. Okay, so now we're getting to the easier ones. It's funny, the ones that look simpler are actually harder than these. Right? So pause the video and try to solve these. Do not, under any circumstance, do not multiply out x plus 8 to the 4th. We're going to do these like we did the square roots. Right? What's the inverse of something to the 4th power? The 4th root. So x plus 8 equals, what's the 4th root of 625? That's just 5. But because it was to the 4th, what do we need? Plus or minus. So then we subtract our 8 on both sides, and we get -8 plus or minus 5. Remember, you can't combine that 8 with the 5 right away. We have -8 plus 5, which gives us -3. And we have -8 minus 5, which gives us -13. And those are our two answers. Number 14. Again, 4th root of both sides. This one's actually easier. So we have 2x minus 3 equals, because it's a 4th root, we're doing plus or minus the 4th root of 15. Can we simplify the 4th root of 15, sorry. No, there's no perfect, does a perfect square go in? No, 15 is 3 and 5, that's it. So we add 3 to both sides. And divide by 2. So notice this looks a lot like a quadratic formula. So that does happen, right? So don't overthink it. Isolate, root both sides, solve. Okay, so there's a couple ways to do this, but I'm going to show you the easier way. Students try to rewrite these as roots, but that's way harder. So think about how I would solve 2/5 x equals 10. How do you solve that equation? There are a couple ways. The easiest way is to multiply by the reciprocal. That's not the reciprocal, Miss Fazone. 5/2, 5/2. Right? Those cancel. So you get 50/2, which is 25. Right? So the easy way is to multiply by the reciprocal. So we're going to do the same thing, but we're not multiplying by the reciprocal. We're not going to multiply by the reciprocal. We're going to take the whole thing to the power of the reciprocal. So if I raise this, both sides, the 2/3 becomes to the 3/2. Right? Because what do you do to the exponents when you're a power to a power? You multiply. So that's x minus 2 to the 6/6, which is just x minus 2. And then we can rewrite this, 3/2. Now I'm going to write it, the 9 is a root. That's the square root of 9 cubed. The square root of 9 is 3. 3 to the 3rd is 27. Add 2 to both sides, and you get 29. And that's it. All right? So try 16 on your own now. So again, we're going to take the reciprocal exponent, so 4/3. 4/3. That's 12/12, so just 2x minus 5 equals the cubed root of 8 to the 4th. Now, you can do 8 to the 4th if you really want, but I do not recommend it. The cubed root of 8 is 2, so then 2 to the 4th is 16. So 2x minus 5 equals 16. Add 5 to both sides. Divide by 2. Done. Okay? Okay. You know what? We're going to skip this one. We don't need to do that. All right, so let's just do one more. I'm going to replace this with x to the 5/3. Oops. All right. So how do you think we'd solve this one? So we need to isolate what's being raised to the power. So we're going to divide by 2 first. So x to the 5/3 equals 32. Now that that's by itself, we're going to raise this and take the reciprocal exponent. So 3 over 5, 3 over 5. X equals the 5th root of 32 cubed. The 5th root of 32 is 2, so 2 to the 3rd is 8. All right. Now, don't confuse this. Well, a lot of kids weren't dividing in class versus this. All right, so these are different, right? This one, because of the parentheses, you do the root first. So for this one, I would raise this to the 3/5 first. And then, so I would 2/6 to the 5th root of 64 cubed. And then divide by 2, that's not simplifiable. Like, that's my answer. I mean, you could try to simplify it, but it's pretty gross. So don't confuse the two. Parentheses, it stays. You have to do the root first. Constant in front, you have to divide first. All right, so don't mix those up. All right, that's all we got.